So this is the second video that I have on phase changes. Hopefully this isn't as dark as the one before. I got some light coming in. So this is obviously a cooling curve, and it goes like this. And since it's a cooling curve, it's giving off heat energy, so it is exo. And it's going from gas to liquid to solid. Gas to liquid to solid, and going down, this is all gas. This is gas to liquid, this is liquid to solid, and this is pure solid. Now there's a question on your packet, and it's very confusing. So the question said, how many minutes does it take to go from the beginning of the liquid state until the substance is totally frozen? So this is a little tricky because the first evidence of liquid would be when the gas is condensing into a liquid right here. But the liquid state starts right here, right at 5 minutes. And when the substance is totally solid or totally frozen, that would be right here. So we are going from 5 to 9. So the real answer is 4 minutes. And on your packet it says 7. But from the beginning of the liquid state to where it's totally solid is 4 minutes. But the other question is from the start of the liquid to where it's totally frozen. That would be 7, but disregard the 7. That's not the question. So today's little video is going to be dealing with the 3 formulas of the phase change. So it's the heat of fusion formula, the heat of vaporization formula, and Q equals M delta T C. So we're going to get over some of those, and hopefully after we're done, you can get done all the questions on your phase change packet. And don't forget, email me if your group can't figure out one of the questions. But you have all the answers to them, but I want you to email me if you don't understand. Okay, here we go. First question. So the question is, 30 grams of a substance takes 2,500 joules to melt this solid. Find the heat of fusion. So maybe you should pause it and try to figure it out and then start it up again. But the formula, a very easy one for the heat of fusion. Q equals M times HF. And this time you know Q and you know M. So we are looking for this. So all you got to do is plug in 2,500 joules equals 30 grams times HF, and that's what we are looking for. So just get that 30 grams, you're going to slide it underneath here. You're going to knock the zeros off, so it's actually going to be 200 250 divided by 3. And when you do that, the heat of fusion equals 83 joules per gram. Now think about this. This is important. 83. Water takes 334 joules to melt 1 gram of ice. This solid can be melted by 83. So the question is, this substance, does it have stronger or weaker intermolecular forces than water? Well, obviously, since water is 334 joules per gram and this is only 83, this has a weaker intermolecular force between the molecules. Everybody got that? That's a pretty good one. So this heat of fusion, remember it means melting, and there's only 3 things you can solve for: heat energy Q, mass, or heat of fusion. So I think we're good with that one. There's a couple on the packet that you need to do. All right, let's go next one. This is going to be the heat of vaporization. So it says find the mass of water given 16,450 joules per gram. Now, we're finding the mass of water, but this is for the heat of vaporization. So you may want to pause your video and then bring it back. Remember the formula is Q equals M times HV. That's the formula, and since we know this is water, we know that HV equals 2,260 joules per gram. That's how much heat it takes to knock out 1 molecule of water to turn it to vapor. So here we'd simply go Q, which is this, 16,450 joules equals M times 2,260. So now simply to get M by itself, we're going to drop the 2,260 underneath 16,450. Let's see what we got. So M, rounded to the nearest gram, is about 7 grams. That's about 7 grams. So whenever they talk about vaporization, you're going to use this formula. Whenever they talk about fusion, you'll use the heat of fusion formula. Now, the toughest formula of all is coming up. And this one, I'll show you where it's supposed to be. Remember, the phase change diagram looks like this. And on the plateaus, there's a phase change. So there's a phase change here, there's a phase change here. This is fusion, which means melting. and this is vaporization, which means you vaporize. Now, the formula for fusion, this is Q equals M times HF. We did that first of all. This one is Q equals M times HV. But the hardest one of all is from here to here. So it's right between the first plateau and the second plateau. And this is a tough formula. This Q equals M times delta T times C. So there's your formula. It's got a change in temperature because the temp is changing. Now, obviously, there's no delta T for the fusion because there's no temp change. Remember, the heat is being used to break the ice bonds. There's no delta T for Q equals M times heat of vaporization because the heat is being used to break the hydrogen bonds. Yes, class, and I absolutely know you know what hydrogen bonds are since you are making hydrogen bonds in each of your classes. But some look pretty weak, man, I'm telling you right now. But remember, they're strong intermolecular forces. That's why we need so much energy to break them. Bonds. That's why it's so high at 2,260. So, and don't forget, this nasty little thing is specific heat. That's how fast or how slow something heats up and cools down. And remember, water has the highest specific heat of any natural substance on Earth with a 4.18 joules per gram Kelvin. That's a lot. Most metals have a specific heat of less than 1, which means they heat up fast and they cool down fast. Okay? Now the space shuttle tiles have a gigantic specific heat, but they're not natural like water. Okay, so let's do one of these problems. We're going to do about 4 of these problems because these are the toughest ones. So it's going to be find the specific heat given 7,500 joules which are absorbed by 20 grams of H2O, which makes the temp increase from 12 degrees C to 21 degrees C. All right, so these are pretty intense questions. So we're going to find specific heat. So first of all, what you got to do is you got to write down the formula. You know you're not going to use heat of fusion and you're not going to use heat of vaporization because there's a temp change. So it is Q equals M times delta T times C. That's what we're doing. And what we're looking for is we are looking for specific heat, which is right here. So what I did wrong is this is not water because we're finding the specific heat of it. So sorry. It's just of a liquid substance. Kind of blew that one. Cooper, don't say a word. Okay, now let's plug them in. 7,500 joules equals 20 grams times temperature change. Temperature change is 9 degrees times what we're looking for, C. So what we have to do is we have to multiply 20 times 9. So that would be 180. We put 180 underneath here. You can knock off that 0, and it would be 750 divided by 18. And that's 42. So the specific heat of this is 42 joules per gram, and this time we did it in degrees C. Now, look at it. What did I say had the highest natural specific heat of any substance on Earth? Water. Water has a specific heat of 4.18. This has a specific heat of 42. So this certainly is not a natural substance. With a specific heat of 42, that means it really heats up slowly and really cools down slowly. So what we found could possibly be space shuttle tiles, because they absorb heat so slowly and they release it so slowly. So that is what that could be, space shuttle tile. Now, that was a tough problem, but we're going to do some that are a little bit tougher. Okay, so it looks pretty simple. Find the heat energy needed to heat 15 grams of water from 25 to 30 degrees C. But watch, so many people blow this question. So first of all, there's a temp change. If there's a temp change, you're going to use this. Q equals M times delta T times C. And we are going to find Q. So all we got to do is we plug in, we're going to go Q equals 15 grams times 5 degrees C. Now here's the part that people forget about. You got C up there. That's specific heat. You got to put it in there. So it would be times 4.18 joules per gram degree centigrade. Now it's complete. So all you have to do is multiply all those together and you got your answer. So I'm not going to do it, you do it yourself. Now, remember, there are several variables, but the toughest questions of all, they will say find the initial temperature or find the final temperature. They are killer questions. So we're going to do 2 of them today. So this would be like one of those questions. Okay, so check this out. It says find the final temp given 850 joules of heat absorbed by 20 grams of water. The initial temperature of the water was 18 degrees. So you're going to go, okay, why is this hard? Well, first of all, final temp. You're going to have to do something. And whenever you're here, the question wants initial temperature or final temperature, you got to solve. Are you ready? You got to solve for delta T first. So you got to plug all this stuff in and solve for delta T. So the first thing you're going to do is 850 joules equals 20 grams times delta T times 4.18 joules per gram degree C. So the very first thing, you got to find delta T. So it's going to be 20 times 4.18 . And then you're going to divide whatever that is into 850. And you come out with this. Delta T equals right around 10 degrees C. So you have to find delta T first. Then you have to go back up into the equation and see what about the heat. Was it absorbed or released? Because if it was absorbed, that means the temperature is going to go up to the final. If it was released, that means the temperature is going to go down to the final. So look. Oh, look, it says absorbed. So if the question says it's absorbed, you know the temperature is going to go up. So it started at 18 degrees. You're going to add 10. So your answer here is 28 degrees centigrade. That is your answer. You've got about 5 questions in your packet doing this that I didn't give you the answers to. And that was on purpose because these are tough ones. You're going to have to talk about it in your group. And remember, if you have a question about it, email me. But only after if you can't figure it out from your group. All right, we're going to do one more of these. Okay, so once again, always look, does it say initial or final temperature? If that's what they want, you got to solve for, yes, Owen, delta T. And that says initial temperature, so we have to solve for delta T. So, 500 joules equals 15 grams times delta T, that's what we have to look for, times 4.18 joules per gram degree C. So you have to multiply 15 times 4.18. and that's about 63. So delta T, oh, sorry. 15 times 4.18 is 63. So now we go 500 divided by 63. And delta T rounded to the nearest degree is, I think, about 9. Let's make sure. No, it's 8. 8 degrees. 8 degrees centigrade. Now, next step. After you solve for delta T, you got to look up there and see, was heat absorbed or released? If it was absorbed, you are going to go from initial temperature up to the final temperature. If it was released, you're going to go from initial temperature up here, and it's going to cool down to the final temperature. So let's see what it says. It says released. So if it's released, the initial temperature is going to be up here, and the final temperature is going to be down there. Okay? So, if the final temperature is 35, what was the initial temperature? Well, all you have to do is you got to add 8 plus 35. And that's 43 degrees C. So it went from 43 degrees C down to the final temperature. I hope you understand that. Those are the toughest questions. So now we've gone over heat of fusion questions, heat of vaporization questions, and Q equals M delta T C questions, which are the toughest. Now, kids, chem kids, you can do the entire phase change packet. So like I said, if you have problems, you let me know on my email. Now, you should have your gas laws test done also. And if you have any questions, remember, ask your group first, but if you still don't understand it, then you email me. All right? Second video is a wrap.